Hello! In this video tutorial on C++, I want to talk to you about the pointer. And let's get started with an example. So, in the last tutorial we declared an array, for example, int array 5. And I tried to explain you how the arrays work, what is behind it. So if we write out the array, write out count array and end line, what do you think what is going to happen? It's going to happen that it will write out the hexadecimal number, which is the where is it in the memory. So let's compile the program. G++ first.cpp, like that, and the output file will be AST, I think. Okay, run it, and as you can see, it is a hexadecimal number. This is where is it on the memory. If you run the same command and with the same program on your machine, it will give probably another number. It is just indicate where is it in the memory. Okay, and I tried to explain you last time. If we want to get the first element of the array, so array 1, this means we add to this number, this hexadecimal number, to the size of integer, that's probably 4 bytes. So if we write out the address of it, so that is the address of operator, this is a one operand operator, and yes, it is a one operand operator. And to make it array, and like that. So first we write out the array and then the address of the first element. You can use it you can use that address of operators actually in any variables. So let's see, compile the program and run it. I think we have a little problem here, and what, I don't save it. Okay, now run it, and as you can see, it is actually 4 byte bigger number. The second is 4 byte bigger number, I think. D, E, F, yeah, 4 byte bigger number. So it is just as simple as that. If we want to write out the array 4, because 5 is not element of the array, it will be array, so the first element, and plus size of so the first element plus size of types multiplied by n minus 1. This is what I want to say. Okay, and you can make a pointer. So int the star, actually asterisk symbol, actually operator, and the name of the variable, like in any case like any other variable, for example pointer, not painter, pointer, like that. So this is a pointer right now. So if we declare another variable like int a equal 42, so we could make the pointer to point the address where A is. Okay, I show you pointer, make it equal to and sign. This is the address of operator A. So the pointer, make the pointer, so let the pointer point to the address of A. Okay, and write out the address of A, and let's write out the pointer to pointer and make a new line after it. Okay, compile and run the program, and yeah, that's it. It is the same. Okay, what happened if I want to write out what the pointer is point to? We use another star symbol, so asterisk, like that. It will give what is it point to. So run the program, and as you can see, it is answer to everything. It is actually called indirection. So we get what is it point to. In case it is 42, if I change the value of I, so I equals 7, then it doesn't change the address of it, so the pointer will give 7, although we don't change nothing about the pointer. So compile the program and run the program, and as you can see, we get 7. Actually, that's it behind the pointers. And why do we need pointers at all, you may ask? And for example, in case of arrays, we give to a function to just the first, so just the address of the first element. So make a function right here. It will be void array element, like that, and it will get an pointer, integer pointer A, for example, and like that. So this is the first element of the array, and write out the fourth element of the array. So count A4 and a new line, and delete these and make an integer array, like that, equals I don't know, 4, 3, 5, 5, just some random numbers. Okay, and array element, and give it array. I should be mentioned that the parameters don't have to be the same name, so it could be anything. In this case, I will just give the first elements array, so in this case this fourth address. Yeah, so the first element's address, that's what I want to say. And with normal indexing we could write out the fourth element, so it will be 0, 1, 2, 3, 4. It should be 8. Okay, save and compile, run the program, and it gives 8, as you can see. So we just give the first to the address of the first element. If we would give the entire array like that, it would be much more time, because it has to copy that value by value. So, and it will use much more memory. Okay, and why else do we need pointers? For example, if you make an, a data type later, a big data type, I don't know, you want to store books in your memory, and you make a function, and you don't have to uh, copy that entire book value, so that entire type value. You have to just give the first to the address, start address, and your function indirects it and can use it. Simple enough, right? And there are the dynamic memory management we will talk about later. When you reserve memory in the free storage with new and delete with delete, and yeah, that's it. You will get the pointer with new, and you have to give the pointer with to delete. Okay, doesn't matter. And there are standard containers in the standard template library STL, which uses that, so it can contain elements, and you don't tell it when you create it how much element do you want. So in runtime you can delete elements, make new elements, pushbacks new elements, so it could be runtime done at runtime. And a lot of other things we need. Pointers, this is just a few that could be a good example and can be easily understand without more knowledge of C++. Okay, I think it should be enough for now, and I make a tutorial next time. I don't know for what. Have a great